Hello students, and welcome to the lecture on computer organization and architecture. After this lecture, we will be able to learn the following objectives. Understand the central processing unit. Explain the communication among various units. Discuss instruction format and instruction cycle. Describe the instruction set and components inside a computer. Explain data representation in a computer. Understand coding schemes in a computer. Let's start with the introduction of computer organization and architecture. The components from which computers are built is computer organization. In contrast, computer architecture is the science of integrating those components to achieve a level of functionality and performance. It's as if computer organization examines the lumber, bricks, nails, and other building material, while computer architecture looks at the design of the house. At each level, the designer is concerned with structure and function. Structure, the way in which the components are interrelated. Function, the operation of each individual component as part of the structure. Now we will study the Central Processing Unit, or CPU. The CPU is the primary component of a computer that processes instructions. It runs the operating system and applications, constantly receiving input from the user or active software programs. It processes the data and produces output, which may store or be stored by an application or displayed on the screen.
What is the CPU? CPU is the Central Processing Unit. Everyone know that, so I'm not talking about it. So let's move to other slide. CPU used in your computer, your calculator, your mobile phone, car, toys, and lot of components. And in the CPU have main three parts. Okay, the first one is the CPU, that means the control unit. The second one is the ALU, that means the arithmetic logic unit. The third one is the memory. Let's talk about each and everything, what is happening and what are these. ALU is done a lot of calculating. That is the part of doing the calculation, every single calculation in your CPU. And the registry and the cache, that is in the memory. The memory location built right into your chipset, in CPU chipset, and it is really fast. It's not like your DDR2, DDR3 memory. It's really fast, but it's the capacity is too low. Capacities around cache is around 2 MB. Sometimes they are 12 MB, but 2 MB. Now the newer i3 processors having 256K. So in the CPU is control every single thing in your computer, like the input devices, output devices, everything is controlled by the CPU. The processors, most of people know about the processors, the AMD and the Intel. There are other processor types like Apple G4 processor and Motorola processors, and there are some other processors. They are not really famous, but like a VIA, but I'm not including that. So that's it. You don't want to worry about it. Just you want to remember about the three part about that: the LU, CU, and the memory. That is the thing you have to remember.
There are three major parts of the CPU: Arithmetic Logic Unit, or ALU, Register Set, Control Unit. Arithmetic Logic Unit. An arithmetic logic unit, ALU, is a digital circuit that performs arithmetic and logical operations. The ALU is a fundamental building block of the central processing unit of a computer, and even the simplest microprocessors contain one for purposes such as maintaining timers. Registers. Registers are temporary storage areas for instructions of data. They are not part of the memory. Rather, they are special additional storage locations that offer the advantage of speed. Registers work under the direction of the control unit to accept, hold, and transfer instructions or data and perform arithmetic or logical comparisons at high speed. The control unit uses a data storage register the way a store owner uses a cash register, as a temporary, convenient place to store what is used in transactions. Computers usually assign special roles to certain registers. An accumulator, which collects the result of computations. An address register, which keeps track of where a given instruction or piece of data is stored in memory. Each storage location in memory is identified by an address, just as each house on a street has an address. A storage register, which temporarily holds data taken from or about to be sent to memory. A general purpose register, which is used for several functions. Control unit, or CU. The control unit is that portion of the processor that actually causes things to happen. The control unit issues control signals external to the processor to cause data exchange with memory and I/O modules. The control unit also issues control signals internal to the processor to move data between registers, to cause the ALU to perform a specified function, and to regulate other internal operations. Input to the control unit consists of the instruction register, flags, and control signals from external sources, for example, interrupt signals. System bus. A bus is a communication pathway connecting two or more devices. A key characteristic of a bus is that it is a shared transmission medium. Multiple devices connect to the bus, and a signal transmitted by any one device is available for reception by all other devices attached to the bus. If two devices transmit during the same time period, their signals will overlap and become garbled. Thus, only one device at a time can successfully transmit. Main memory unit. Memory is that part of the computer which holds data and instructions for processing. Logically, it's an integral component of the CPU, but physically it's a separate part placed on the computer's motherboard. Memory stores program instructions or data for only as long as the program they pertain to is in operation. The CPU accesses the main memory in a random manner. That is, the CPU can access any location of this memory to either read information from it or store information in it. The primary memory is of two types: random access memory, or RAM, read-only memory, or ROM, cache memory. It is a small, fast memory that is inserted between the larger, slower main memory and the processor. It holds the currently active segments of a program and their data. Types of cache memory. The cache memory is of two types. They are primary, processor cache, level 1 or L1 cache, secondary cache, level 2 or L2. Primary cache. It is always located on the processor chip. Secondary cache. It is placed between the primary cache and the rest of the memory. Did you know the first documented computer architecture was in the correspondence between Charles Babbage and Ada Lovelace, describing the analytical engine? Now we will study communication among various units. All units in a computer system work in conjunction with each other to formulate a functional computer system. To have proper coordination among these units, for example, processor, memory, and I/O devices, a reliable and robust means of communication is required. One of the most important functions in the computer system is the communication between the units. Processor to memory communication. Processor to I/O devices communication. Processor to memory communication. The whole process of communication between the processor and memory can be divided into two steps, namely information transfer from the memory to processor and writing information in the memory. Processor to I/O devices communication. When I/O devices and memory share the same address space, the arrangement is called memory mapped I/O. Let's now understand the instruction format. An instruction format defines the layout of the bits of an instruction in terms of its constituent fields. An instruction format must include an opcode and implicitly or explicitly 0 or more operands. The format must implicitly or explicitly indicate the addressing mode for each operand. For most instruction sets, more than one instruction format is used. Computers understand instructions only in terms of zeros and ones, which is called the machine language. To accomplish significant tasks, the processor must have two inputs, instructions and data. The instructions tell the processor what actions need to be performed on the data. These are transferred one at a time into the processor, where they are decoded and then executed. Each machine language instruction is composed of two parts, the opcode and the operand. The bit pattern appearing in the opcode field indicates which operations, for example, store, add, sub, and so on, are instructed. Now we will learn about the instruction cycle. The basic function performed by the CPU is the execution of a program. The program to be executed is a set of instructions which are stored in the memory. The CPU executes the instructions of the program to complete a given task. The CPU fetches instructions stored in the memory and then executes the fetched instructions within the CPU before it can proceed to fetch the next instruction from the memory. This process is continued until specified to stop. The instruction execution takes place in the CPU registers, which are used as temporary storage areas and have limited storage space. The instruction cycle includes stages as fetch, read the next instruction from the memory into the processor; execute, interpret the opcode and perform the indicated operation; interrupt. If interrupts are enabled and an interrupt has occurred, save the current process state and service the interrupt. Let's now learn about the instruction set. Processors are built with the ability to execute a limited set of basic operations. The collection of these operations is known as the instruction set of a processor. An instruction set is necessary so that a user can create machine language programs to perform any logical and/or mathematical operations. The instruction set is hardwired or embedded in the processor, which determines the machine language for the processor. The more complex the instruction set is, the slower the processor works. Based upon the instruction sets, there are two common types of architectures: complex instruction set computer, CISC, reduced instruction set computer, RISC. CISC architecture. CISC, which stands for Complex Instruction Set Computer, is a philosophy for designing chips that are easy to program and which make efficient use of memory. Each instruction in a CISC instruction might perform a series of operations inside the processor. This reduces the number of instructions required to implement a given program and allows the programmer to learn a small but flexible set of instructions. RISC architecture. The RISC architecture is a dramatic departure from the historical trend in processor architecture. An analysis of the RISC architecture brings into focus many of the important issues in computer organization and architecture. Although RISC systems have been defined and designed in a variety of ways by different groups, the key elements shared by most designs are these: a large number of general-purpose registers and/or the use of compiler technology to optimize register usage, a limited and simple instruction set, an emphasis on optimizing the instruction pipeline. Now let's take a look at what is inside a computer. Computing machines are complex devices made from numerous electronic components. Many of these components are small, sensitive, expensive, and operate with other components to provide better performance to the computing machines. Therefore, to better ensure a performance and increase the life of these components, they are placed inside a metal enclosure called the system case or cabinet. The system case is a metal and plastic box that houses the main components of the computer. It protects electronics hardware against the heat, light, temperature, etc. It serves important roles in the functioning of a properly designed and well-built computer. Several areas where the system case plays an important role are structure. The system case provides a rigid structural framework to the components, which ensures that everything fits together and works in a well-organized manner. Protection. The system case protects the inside of the system from physical damage and electrical interference. Cooling. The case provides a cooling system to the vital components. Components that run under cool temperature last longer and are less troublesome. Organization and expandability. The system case is a key to the organization of physical systems. If a system case is poorly designed, upgradation or expansion of a peripheral is limited. Status display. The system case contains lights or LEDs that provide varied information pertaining to the working of the system to the user. Power supply, SMPS. All electronic systems and equipment, regardless of their size or function, have one thing in common. They all need a power supply unit, or PSU, that converts input voltage into a voltage or voltages suitable for their circuits. The most common type of today's PSU is the switch mode power supply, SMPS. There is a wide variety of SMPS topologies and their practical implementations used by PSU manufacturers. However, they all use the same basic concepts. AC to DC converters and DC to AC converters belong to the category of switched mode power supplies. The various types of voltage regulators used in linear power supplies, or LPS, fall in the category of dissipative regulator, as they have a voltage control element, usually a transistor or Zener diode, which dissipates power equal to the voltage difference between an unregulated input voltage and a fixed supply voltage, multiplied by the current flowing through it. Now we will study the motherboard. The motherboard is a printed circuit board that is the foundation of a computer, and it allows the CPU, RAM, and all other computer hardware components to function and communicate with each other. The motherboard is also known as mainboard, MOBO, M-O-B-O, which is an abbreviation, MB, which is an abbreviation, system board, or logic board. Expansion cards. An expansion card is an electronic card or board that is used to add extra functionality to a computer. It's inserted into an expansion slot on the motherboard of a computer. Expansion cards contain edge connectors that are used to create an electronic link between motherboard and card, thus enabling these two to communicate. Ribbon cables. A ribbon cable is made up of a number of wires that run alongside each other in parallel. The majority of ribbon cables are found on the inside of electronics. It's also called a multi-wire planar cable. Memory chips. It is a chip that holds programs and data either temporarily or permanently. RAM chips are the computer's temporary workspace, while flash memory chips are used like disk drives, permanent until erased. ROM and PROM chips can never be changed, while EPROMs can be modified, and also EEPROMs can be modified. Storage devices. Storage devices are the data storage devices that are used in the computers to store the data. The computer has many types of data storage devices. Some of them can be classified as the removable data storage devices, and the others as the non-removable data storage devices. Processors. A processor or microprocessor is a small chip that resides in computers and other electronic devices. Its basic job is to receive input and provide the appropriate output. While this may seem like a simple task, modern processors can handle trillions of calculations per second. Let's now learn how data is represented in a computer. Data representation refers to the methods used internally to represent information stored in a computer. Computers store lots of different types of information: numbers, text, graphics of many varieties, stills, video, animation, and sound. Memory structure in a computer. Memory consists of bits, 0 or 1. A single bit can represent 2 pieces of information, bytes, which equals 8 bits. And a single byte can represent 256. 2 times 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 2 equals 28 pieces of information words, which equals 2, 4, or 8 bytes. A 2-byte word can represent 2562 or 2,562 pieces of information, approximately 65,000. Binary numbers. Normally, one writes numbers using digits 0 to 9. This is called base 10. However, any positive integer, whole number, can be easily represented by a sequence of zeros and ones. Numbers in this form are said to be in base 2, and they are called binary numbers. Text. Text can be represented easily by assigning a unique numeric value for each symbol used in the text. For example, the widely used ASCII code, American Standard Code for Information Exchange, defines 128 different symbols. When one saves a file as plain text, it is stored using ASCII. Graphics. Graphics are displayed on a computer screen, which consists of pixels, tiny dots of color that collectively paint a graphic image on a computer screen. Compression. The basic idea of compression is to make a file shorter by removing redundancies, repeated patterns of bits from it. This shortened file must, of course, be decompressed, have its redundancies put back in order to be used. However, it can be stored or transmitted in its shorter compressed form, saving both time and money. Types of number system. There are 4 number systems that are decimal number system, binary number system, octal number system, hexadecimal number system. Now we will study the coding schemes. In today's technology, the binary number system is used by the computer to represent the data in the computer, understandable format. Numeric data, 0, 1, 2, etc. to 9, is not the only form of data which is handled by the computer. Binary coding schemes. The alphabetic data, numeric data, alphanumeric data, symbols, sound data, and video data are represented as combinations of the bits in the computer. The bits are grouped in a fixed size, such as 8 bits, 6 bits, or 4 bits. A code is made by combining bits of definite size. American Standard Code for Information Exchange Code. The standard binary code for the alphanumeric characters is the ASCII. This code was originally designed as a 7-bit code. Several computer manufacturers cooperated to develop this code for transmitting and processing data. They made use of all 8 bits, providing 256 symbols. In the ASCII, the uppercase letters are assigned codes beginning with the hexadecimal value 41 and continuing sequentially through the hexadecimal value 5A, and lowercase letters are assigned hexadecimal values of 61 through 7A. Now in the end, let us summarize what we have learned in this lecture. The CPU is the primary component of a computer that processes instructions. It runs the operating system and applications, constantly receiving input from the user or active software programs. Registers are temporary storage areas for instructions or data. They are not part of memory. Rather, they are special additional storage locations that offer the advantage of speed. The control unit is that portion of the processor that actually causes things to happen. The control unit issues control signals external to the processor to cause data exchange with memory and I/O modules. To accommodate interrupts, an interrupt cycle is added to the instruction cycle. In the interrupt cycle, the processor checks to see if any interrupts have occurred, indicated by the presence of an interrupt signal.